Hello folks, hope all of you doing good. In the fourth segment of design of irrigation canals, we shall be looking into the design procedures adopted in Lacey's theory. Before that, uh, Lacey argued that the sediment is kept in suspension not only by the vertical component of eddies which are generated on the channel bed, but also by the eddies generated on the sides of the channel. On the other hand, Kennedy had neglected the eddies which are generated on the sides of the channel by presuming that such eddies has horizontal movement for greater part and therefore do not have sediment supporting power. So the design procedure must and should follow the orders. The silt supporting power is proportional to the wetted perimeter of the channel. That is what evident from the Lacey's concepts. The grain size of the material forming channel is also an important factor, and Lacey introduced for which a term called silt factor. Silt factor is F, and silt factor is correlated with the average particle size. Let us look into the design procedure for a stable channel according to the Lacey's theory. First thing is calculate the velocity. We calculate the velocity from this equation. V equals to q f square divided by 140 whole to the power 1 by 6. Velocity is obtained in meter per second, where q is in cubic and v is in meter per second. That's a velocity. And how do we calculate f? F is the silt factor. F is calculated with one more simpler formula. F equals to 1.76 square root of d, which is in terms of millimeters here. D mm or d millimeter is the average particle size which can be obtained for silt, sand, gravel, boulders and bajri and sand types of materials. Second one is, once we are done with the calculation of velocity, one is supposed to work out the hydraulic mean depth, that is R, and that can be found out from the equation R equals to 5 by 2 times V square by F. V again, it's the velocity in meter per second, and R is calculated, which would be in terms of meters. Compute the area of channel section, that's about A. A is, as all of us know from the bit of equation, Q equals to area into velocity. A is Q divided by velocity. The wetted perimeter is computed later. Wetted perimeter P is 4.75 times the square root of Q, where P is in meters, wetted perimeter, Q is the discharge in cubic or meter cube per second. Now, by knowing these values, the channel section is known, and finally the bed slope S is determined by the equation S equals to F to the power 5 by 3 divided by 3340 into Q to the power 1 by 6, where F is the silt factor, Q is the discharge in cubic. Hope you have understood the procedure for designing a stable channel from the Lacey's theory. Thank you.